Then, so can you give like a brief 1 minute intro about like yourself, I guess?
Okay. And then real quick, how do I switch the language on here?
Which one do you want? I can switch it. Oh, it looks
Python.
like you got it. Okay.
Oh, I see. You just click on the left here. Okay,
Mhm.
cool. Perfect. All right, I'm ready.
Okay. So yeah, let's start with like a 1 minute intro about yourself, and then we can move on to the problems.
Cool. Did you want me to start
Yeah,
now?
yeah. Sorry.
Cool. So yeah, I'm still in school right now as a software engineer student. Looking for new grad roles currently, mostly at the FAANG level. I have an interview this week and kind of want to just see where I'm at and see if if I can do well in these interviews. I have like 200, 300 problems on LeetCode, but honestly, I'm not super strong, so I kind of want to just keep practicing as much as I can and just making sure I'm ready. So yeah, that's kind of where I'm at.
Okay, great. So what we're gonna do is we're gonna do two problems, 50 minutes. So it's 12:04. So we'll go on 12 until 12:54. I've been going over with people, but I'll just have a hard stop at 12:54, no matter where you're at. So let me paste the first one.
Okay.
Right. Just gonna get rid of, or I'll like paste it up here. Okay. And you can go ahead.
Did you paste the? Let me reload
I
my
pasted it
screen.
in the Python, I think. Are you not able to see it?
No, it just shows your cursor.
Maybe refresh the coder pad.
Yeah. Yeah, it just shows. I can share my screen to show you what you're
Sure.
seeing.
That is strange.
Yeah.
Okay, let me refresh the coder pad and then let me paste again. Okay. Maybe I have to refresh actually. Oh
No
no.
worries.
Yeah, this thing gets kind of buggy sometimes. Okay, let me try it again. All right, and let me know if this works. Okay, so
There we go. Yeah. Okay. All right. So I'll get started now. Okay. So the question is: a string can be abbreviated by replacing any number of non-adjacent, non-empty substrings with their lengths. The lengths should not have leading zeros. Okay. So let me take a quick look at these examples.
mhm.
So strings such as substitution could be abbreviated, but not limited to S10N. Okay, so interesting. Okay, so I'm assuming this is 10 characters
Mhm.
between S and N. And then we have this second example where we could do sub and then four characters represented by four, and then U, and then another four characters. Okay, and then we could also just have a case where we just print out the length of the word. Um, okay, so I want to look at where they're not valid. So in this case, it would be okay. So we can't have abbreviations right next to each other. Um, I see, because this would be abbreviated to five. This would be abbreviated to five. So this would not be a valid input because we need something in between here, right? For example, X, right?
Mhm.
Um, Okay, and then this one says it has leading zeros, which means this would not be valid as well because, yeah, I can see that this wouldn't represent anything as an abbreviation. Okay, so given a string and abbreviation, return whether the string matches the given abbreviation. Okay, so we're just checking if this abbreviation matches the word. Essentially, is that correct?
Yeah.
Okay, and then there's a little comment here saying a substring is contiguous. Okay, so it's just saying any like subarray of a string would be a substring. Okay, so okay, in this case, this would be true in the first example because we have the first letter I, and then we just essentially skip 12 characters and then see if the next character is IZ, and then 4, and then M. So I guess this is kind of a question of just formatting the input abbreviation. For example, how do we get 12 out of this? That's kind of, I think, what the question is really asking.
Okay.
So first thing that kind of comes into my head is like doing like modular and times 10 of this input stream. So what I mean is if you look in the first example, so what I would do is for every substring that is a digit, so if I copy this right here, and let's say our index right now is 0, and then we iterate through I, which is not a digit, and then we go to the next index, and then the digit is 1. So while the current index is a digit, we have, well, I guess I'll call them lengths, an array that stores the lengths. So what I would do is have current length as well equal to 1. So what I would do is process 1 and then put that into current length and then times this by 10 and then increase the index by 1, which is now 2. And then if that's a digit, then we add it to the current length and then increase the index. And then if we have finished reading a digit, then we'll just put it into lengths. And then we just continue this for every like substring of digits of the input abbreviation. So in this case, it would be 12.4. So now that I have the lengths, what I want to do now is figure out how I can make sure that the inputs are like matching up with the input string. So let me think about this for a second. So, so if I do I guess what I could also do is actually inside the lengths, what I could do is just make it a little bit simpler for myself and just input the strings that I need to check. So in this case, iz like this, and then at the end, n. And then what I could do is just go through the word and then just match it with the lengths. So in this example, it would be, I think we can, yeah, we just do this. Oops, just copying it down here so it's a little bit more legible. Like this. And then what I would do is just essentially match that. So I would go through lengths, check if I is equal to this stream, and then I see 12. So I would skip essentially 12 characters, and then I would put in iz and then check if iz is correct, and then skip another 4 and then see if it matches with n. Does that make sense so far?
Yep, makes sense.
Okay. Now I'm thinking of any potential edge cases. For example, the leading zeros, like it mentioned in the problem description, where we could have leading zeros. My question is, can the abbreviation input have zeros in it? For example, this 0, 1, 12.
So it can't have 0, 1, 12, right? So it can, but this should be basically actually let me take one more time. Yeah, so basically this should return false, I believe,
Okay.
because there's a leading 0, right? So this should be false. So anytime you have like an invalid abbreviation, you can just return false.
Okay. So I guess to check for this, we can just initially check if we started with a digit, and if it's initially a 0, then we can just return false. And that's what I would do in that case. Okay, now another edge case, I guess, is like an empty abbreviation. Like, for example, if it was just empty. I'm guessing this is going to return false as well because there's no abbreviation, right?
Yeah.
Okay. Okay, I think I'm trying to think if there's any other maybe potential edge cases. I don't think of one. Maybe we'll come up with one as we go with the solution. I believe this should be good. Okay, so I'm gonna go ahead and start writing the code for this.
Sure.
So the plan is kind of what I mentioned before. So we'll kind of just work through that. So okay, so
And before you start writing the code, so what would be the time complexity of your approach and like the space complexity?
Okay, so space would be linear because we have to store lengths of a certain amount. For example, worst case, it could be of the length of the string. For example, if it's like 1, 1, 1, 1, 1, yeah, that would be worst case. And then time complexity, I believe, would also be linear because I'm essentially just parsing the input. one by one, and for every digit, we're just multiplying the current length by 10 and then adding to that.
Okay, and then
One,
the other
yeah, go
thing
ahead.
is, oh yeah, go ahead. Sorry.
No, let's go ahead, sorry.
Yeah, I was gonna say. So you have these lengths, right?
Mm-hmm.
So when you get to one of these, like, how are you gonna know if I want to compare it to the string, or if I want to compare it, like, or if I want to jump? Like, are you gonna check for like the type,
Mm-hmm.
or like,
Yeah, so what I'll do is I'll have, so there'll be like two loops. So the first loop is just parsing the input and then creating the lengths array.
Yep.
And then we'll have another loop that is gonna keep track of an index starting at 0, and then it's gonna go through the length. So at index 0, and it's gonna process this. And then for every character that we process in the current index, we just increment that. So for example, let's say this was IXZ. First, and that, or sorry, the first iteration, we just check with the string starting at the index 0, and then for every character that we go through this, we just increment 1. So at the end of this, it would be 2, and then here we just essentially add this by 12, right? So it'd be 14.
So you're building. So you're essentially building the chunks of the string, like, as you go, right?
Yeah.
So
And
what
then this
if
would be kind of like
so
our
what if
skip
the
flags.
abbreviation was the word, right? Like, it matched exactly. So your length would be just like the entire word, right? Essentially, like your lengths array would just have one thing and it would be the entire word.
Mm-hmm. So
So
you're
when you build the
saying
string, are you going to build like character by character, or how's that going to look?
essentially character by character, right? So like here, we would increment the index by 3, and also while doing that, match it with the input. And then every time we have like a digit here, then we use this as like a skip flag and then
I
increment this
see.
by 12.
Okay.
And now for your question of if it's like the same, so let's say like the abbreviation was the same, it would look like this, right? So what we would do is just go through this iteration and then increment the index one by one. So starting at 0, 1, 2, and then so forth.
Okay. Yeah. Let's just get to the coding, and then if I have any questions about your code, I'll ask you about that.
Okay. So let me see what we have to do here. So we have to parse the input. So I think we'll create some helper functions to help myself for this. So what I'm going to do is create a function called parse input. This will just take in the word itself, the abbreviation. So I'll call this brief. This will return a. I'm not going to worry too much about the type annotations here, but this is going to return
you can get rid
the
of types if you want, if it's
yeah.
faster.
Yeah, so this is just going to return essentially the lengths array. So for now, just do this as a reminder for myself. So the first thing I want to do is get the lengths array. So what I want to say is lengths is equal to parse input of abbreviation. And then let's see here. So now that we have the lengths, what we need to do is kind of do what I was saying earlier, where we use the index to keep track of what character we're currently on, and then we use this to kind of has skip flags to essentially increase the index by a certain amount. So the way I could do that is keep track of an index equal to 0, and then I would do, let's see, so for length in lengths, if the length is digit. I can't remember how you check the length or like the type of. I think it's length is digit for.
You can look that up if you need to.
Yeah,
Check the
okay.
type of something, because in your plan you have strings and digits. I don't think you can do is digit on a digit. I think you can only do it on a string.
Yeah, that's right. Okay, let me quickly check that up then. How to check type of variable in Python. So that is going to be, oh, we just say type. So if type of length is int, then we can do index plus equals the length. Otherwise, it would just be a string, right? So what we need to do is we need to go essentially through each character of the string. So for char in length, if we need to make sure that the character is correct with the word itself. So what I would say is word of index is equal to char. Then we can just do index plus equals 1. Otherwise, we have to return false because it doesn't match correctly. Okay, and then at the very end, if everything's good, we return true. Okay, so what's this saying? Oh, because I was using self instead of the self parse input. Okay, so now I want to go through this parse input, which is kind of the tricky part of the problem. So what I want to do is store an array called lengths in here. And what I want to essentially do is, if the character is a string, then I just want to append it to a current string, which I'm going to call cur string. Actually, I might just call it cur because this could be like an integer or a string, because we might have to change it as we go. And then what I want to do is, for char and abbreviation, if type of char is string, then what I want to do is just do cur plus equals char. Else, that means we reached a digit. First, I want to add lengths for the current string that we have if it has some characters in it. So if length of cur if length of cur, and then we do lengths append cur. Okay. And at the end, I'm going to return lengths here just before I forget. So now that we're at a digit, what we need to do is, so I guess I said earlier this could be a string or an integer, but now I'm thinking, what if we just store it in here? So what if I say cur int is equal to 1, and then while, okay, so while I want to store the index. Okay, so instead of maybe a for loop here, I might do an index here. So maybe index equals here, and then say while index is less than abbreviation, or the length of abbreviation. Index, and then I have to do abbreviation of index here, and then index plus equals 1 here. And then here, I'm going to say while index is still less than the length of the abbreviation, and it's an integer, right? So the abbreviation of index is digit. I believe that's the function call for checking if it's a digit. And then if it's a digit, and then we can essentially append that to the current. So do current times equals, oh, sorry, it would be plus, actually, so we would start at current equals 0 and then current plus equals the digit. So so I would do int of abbreviation of index, and then we would do the times equals 10 to essentially get to the next next one. And then after all of this, we do index plus equals 1. Now there's the case of the leading zeros, and if that's the case, then we have to return false. So if the first one is a 0, then we have to return false here. So if I do index is equal to 0, return false, because, or I guess since this is inside a function, I guess what would be the best way to do this? Maybe if I say -1, and then just check that directly. If length is equal to -1, return false. Okay. So let me make sure I did this correctly, because I know I kind of changed it up as we went. So let's see, so times equals 10, and then we have to add it to the lengths. So once we're done with this, then we do lengths dot append the current. And then once we're done with that, let's say we get to the next character, then we want to essentially reset cur. And we can reset cur probably in here. Cur, yeah, in here. So I would reset cur equals to an empty string again so that we can get to the next one. Okay. So I think that's it. I'm going to quickly dry run this because who knows what could happen. So I'm going to go through a quick example and see if I made any potential mistakes. So I'm going to kind of put it in between so it's a little bit easier to work with without scrolling. Before I go to this dry run, does everything make sense to you so far?
Yep.
Okay. So let's go through this dry run real quick. So we're going to essentially create a length array. For now, it's empty, and we're going to parse the input. So the index is currently 0, and we have an array or a variable called cur, which is equal to an empty string. And then we essentially increment the index by 1 if it's just a digit, and we essentially add that to cur. Otherwise, it's a string, sorry. And then if we reach a digit and it's not 0, we add cur to the lengths. And then we have another variable called current, which is going to essentially keep track of our current digit, which is now going to be 1. And then we're going to increment our index by 1 here. Oops. Is digit. And then current is now 12. And then once we reach the end, then it's going to append it to here. And then now that we're at a string again, it's just going to essentially add it to this empty string called cur, and then continue until we reach another digit. So this will be stored in here, and then 4 will be stored because it's a digit, and then end here. Okay, I think that works. Maybe we'll run into a syntax error, but I think logic-wise makes sense. Does that make sense to you for the parsing the input?
Yep. Maybe you can try running it on the example and see what happens.
Yeah, that's a good idea. So parse. So we'll do this one right here. So print parse input, and then click run. We have an empty array. Okay. Why do we have an empty array?
Oh, you're testing. I see. You're testing parse input. Got it.
Yeah, but why is it an empty array? So the length is this.
Mm-hmm.
Index length of abbreviation. Let's see here. While index is less than this.
So I will tell you one error. This is wrong because your type will always be a string here.
Type of string. Oh, yeah, that is. You're right, because the input's always a string, of course.
Mm-hmm.
So what I could do is just check if it's not a digit. So if abbreviation of index like this.
Mm-hmm.
Okay. So I think we are running through the loop. It's just it didn't pass that if condition. But we should have seen. I'm gonna run this one more time real quick. Okay, it's digit not. Is it lowercase is digit? I think it might be lowercase.
Let me double check. I don't know it off the top of my head.
Yeah, it was lowercase.
Oh yeah.
All right, so looks like we have something now. So the first thing I forgot to do is append cur to the end once we're done. So if there's something inside of cur, then we'll just append it.
Mm-hmm.
The other thing is we times 10 and then appended it. So times equals 10. Let me think about this. So it's trying to think about the ordering here. So it's we do 1, or we start with 0, and we add it, and then we times it by 10. So we can just divide it by 10. So divide this by 10, and then that will just make sure that it's the correct number. Okay, so the input for the parse input now seems correct to me. So let's move on to the rest of the function. So now that the length is correct, I'm just checking if it's -1, because if we had leading zeros, then we just return false. And then now we're actually just going to go through the lengths. And if it's a type of integer, then we're just going to increment by the length. It's essentially like a skip flag. So if we use our lengths here, in the example internalization, and then so if it's not a integer, then we're just going to go through the current string inside of the length, and then we're going to increment the index by 1 if it's a matching character. So here it's going to be index of 0, I is equal, then it's just going to do index plus equals 1, and then now it's going to do 12, so it's going to do 1 plus 12, which is 13, and then it's going to go through iz and then check the index of 13 of iz and then do plus equals 1, and then check z and then plus equals 1, and then so forth. So let me test this now just by doing that example. Generalization. And it's not self here. Okay. So this returns true. Perfect. That's the expected output. And then I want to try the other ones. So for example, the one with the leading 0, right? So let's try that real quick. So this would definitely return false because it's not even the same word. If I do substitution, this should return false as well. If I get rid of the 0, this should return true. Okay. And then, of course, if it's like an empty abbreviation, it should return false. It does not. Okay, so let's figure out, or it's because I had to print out, but yeah, this returns true, which is not correct. So why is that? So parse input, this would return an empty array. Oh, I see. So if it's an empty array, then just return false. So I could just do that up here. If not length of lengths, return false. Oh, that would have to be after the type checking, of course. And that should return false. Okay. Okay, I think that's good. And then, as mentioned before, the time complexity should be linear because for the parse input, it's just we're just going through each character of the abbreviation. So that's going to be O of n. And then the space would be linear as well, which would be O of n as well, because the length could be, worst case, the length of the input. And then for the second part of the function, this would also be linear as well, because it's just we're going through every character of, or like every character plus the skip flag of length.
Okay, so let me try a couple things here. So let's try this. And before we run it, what do you think should happen?
Okay, so if it's the word itself. So this for sure should be false because, oh, this would not be a leading 0, huh? Mm-hmm. I guess this should return. Okay, just for the example itself, I'm guessing that this should be returning false.
It should be true because it's not a leading 0 and it's a substring of length 0.
Of length 0.
Yeah.
Interesting. Okay. Let me see here. Of length 0. Full 0.
And I think this was actually one of the examples they gave where it's yeah.
Yeah,
one of the
right
ones
here.
they pasted. So how can we handle that? And maybe you can just talk about it. Honestly, it's fine. Like, you don't need to change the code.
Yeah, I guess we would just skip it because it's not even like something we put inside of lanes, because it's just an empty.
Oh, so when you parse it, if you get a 0, you'll just skip?
Well, we still have to check if it's a leading 0. So maybe
Yeah, like how do you differentiate leading 0 and 0? Because right now you have like while this thing is 0 return. So
Yeah,
how would you change that to account for both? And yeah, like I said, you don't have to code it. You can just like tell me.
yeah. Well, I mean, I initially was thinking like, what if we just check like the next index after, but then we can get like out of bounds. Um, that actually might
Yeah.
be okay. Just check if like the next index is within bounds,
Mm-hmm.
and then if that next index is a digit,
Mm-hmm.
then obviously we have to return false. Otherwise, if it's not, then we can just skip it essentially because it wouldn't matter for the input. Does that
Yep.
make sense?
Yep. Okay. Then you have another problem, I think.
Oh
So
boy. All
what
right,
should
let's see
this
it.
do?
That should return false, right?
Okay. And if we run that,
So
we get true
returns
again.
true for lengths and lengths. Okay, we just have to make sure that the index is the same length of the word. So here we can say if index does not equal length of word minus one, then return false.
Okay. Makes sense.
Okay.
Okay, cool. And then one other thing, I don't think it's a bug, but you were mentioning like time complexity and stuff.
Mm-hmm.
So you do, where is it? Here. So you do on line 59, or actually not line 59, sorry. On line 55, you're taking, so imagine this whole thing is a string, right? So what would
Mm-hmm.
happen is that your current, like let's say your string is like, I'll try it up here, like A, B, C, D, E or something, or some like whatever. So what you're doing is you're basically saying, okay, cur equals like A, and then I'm going to add B, and then I'm going to add C, and so on,
Mm-hmm.
right? So do you see a problem with that?
See, in Python, I thought this would be a one when appending two strings, but I
Mm-hmm.
guess since you're asking a question, maybe it's could be linear because we have to go through every character
So if
in
I
the
have a
first string.
string that's like 1 million characters and I add A, strings are immutable in almost every language. So you basically create a new string. So even though I'm
Yeah.
only adding one character, I have to like copy the whole thing. So if this gets really long, this becomes unsquared. So do you know how
Hmm.
we could fix that?
I mean, the first thing that comes to mind is like, what if we just used an array
Mm-hmm.
to store the characters and then just build the array every time we append it, and then just turn that into a string essentially. So it'd be like this join and then the array,
Yeah. Okay.
um,
Okay.
so that we
Yep.
could like avoid like repeatedly building the string.
Yep. Okay. All right. I think this is good. Let's move on to the second problem. All right. And I will paste it. Let's just comment out all of this. And I paste down here. And you have a separate thing.
Okay. So given a word, search word. Okay, so given an array of strings and a search word, design a system that suggests at most three product names from products after each character of the search word is typed. Okay, suggested products should have common prefix with the search word. If there are more than three products with a common prefix, return them in alphabetical order. I think that's what it means, right? Lexicographically minimum products.
Yep.
Return a list of the suggested products after each character of the search word is typed. Okay, interesting. So let's go through the first example. So our search word is mouse. And then the input is just an array of words. And the output would be these three words initially. Um, and why is that? That is because it should have a common prefix. If there are more than three, then we just get three words that have, like, they come first in alphabetical order. Does that make sense?
Yeah.
Okay. Okay. So first one would be like type in M, right? And then it would be like, okay, get mobile, money pot, and monitor because they all have O as the second letter, but the third letter, it would be B, N, and then N. and then I think n becomes goes before u, so that makes sense that this is it. And then the second letter would be O, and it would basically just do the same thing. Okay.
Hmm?
Oh yeah, and it explains it here that yeah, if you type M and MO, all the products would show that. Okay, interesting.
Yeah, so you basically just go through one letter at a time. You build the prefixes have to match, and then whatever matches, you just return the first three in like a graphically smallest order. And if there's not
Mm-hmm.
enough, then you just return whatever's there, or empty array if there's nothing.
Mm-hmm. Yeah, like the first thing that kind of comes in my head is like a trie, or like some sort of tree where we just find like all the possible paths after each character.
Okay.
Um, but let me think about this a little bit more. So I guess yeah, if we build a trie, where all the possible paths we can go from well, in this case, it would just be O in this like list of products. And then from O would be all the possible paths after O. What would be B, and then U, and then M. But my question is, I'm asking to myself is, what if we had different letters? Like, for example, let's say in the input we had book.
Mm-hmm.
How do I handle that case? Well, I guess maybe if, I guess if it doesn't start with the character, we can just ignore it because it'll never be in the try.
Okay.
But I mean, you could argue. Well, actually, I think that does work because if it was like for I don't know M Mook,
Mm-hmm.
then we could build the try. So I guess we just skip the words that don't have starting characters, um, and then we just essentially build the try for every character that we type. Um, and of course, it would have to be in lexicographical order, which I think we can handle that in the try. So let me try to draw this out a little bit.
Sure.
Uh, so we build the try. So it would be M, and then O, and then this is going to be kind of hard to type it out. O, and then it would be like B, and then U, and then N. And then I guess for every letter, we can just append the list or like the word that it belongs to. Uh,
Okay.
like I guess it's kind of hard to see in the example, but like I could build a or like append the list of words that it belongs to in this try. For example, here would be like basically the input minus like any of the words that it doesn't start with the, and then here it would be essentially the same thing. And then B, it would actually just store, I'll go below, like mobile, and then I think that would just be it, mobile. And then mobile, yeah. And then let me quickly look through this example to make sure. So it's mouse, but if it was mobile, it should only show mobile, correct? Like for example,
Mm-hmm.
if it was MOB, like this, it should only show mobile, right?
Yeah. Yeah.
Okay. So then yeah, this would be mobile for B, and then U would just store all the words that are associated with that. Um, does that make sense?
I see. So you're basically saying I'm gonna build a try, and then for every character, like as I insert words, for every character they have, I'll insert words into them.
Yeah, and then I guess the question now becomes how do we get the alphabetical order? I mean, first thing
Mm-hmm.
that comes to my head is sorting,
Mm-hmm.
and that might be okay depending on like the time constraints. I'm guessing this has to be relatively efficient. If we
Mm-hmm.
sort it, would be n log n worst case or best case. Um,
Yeah. The
and
other
if
thing
we
I'm thinking of with this try approach is, let's say every word was pretty long, and every word was the same. Um, like or very similar. Maybe let's say like, every word starts with the first like million whatever characters, and then like the last two differ. So you're gonna have like for every single character, you'll have the entire thing, which I think is doable. But can we think? So we can go with this, but can we think of like a simpler approach without using a try? Like we basically just need like graphical characters, and then with every um, with every like a new character we put in, we're essentially eliminating some things that were allowed, right? So for example, when it's empty, it can be the whole array. When it's M, I eliminate some stuff. When I add another character, I eliminate some stuff. So is there
Mm-hmm.
anywhere we can do that efficiently without using a try? And because yeah, for a try, we'd have to for every character keep track of the sorted words. We might
Yeah.
have to sort at every character as well, depending on how you implement this and things like that. So is there anything we can do that's better?
Okay. So if we do somehow take away some words from the input. Um, oh, I guess maybe if I mean, we still have to first take out the letters that it doesn't begin with, for sure. But what
Sure.
if we sort the input, maybe? If we sort the input,
Okay.
I feel like that could work. So what we could do is say, so for example, mouse, right? If we sort the input, it should look like this,
Mm-hmm.
right? And then we check the first index, see if it matches. If it does, then we append it to the possible list of words.
Mm-hmm.
Um, if it doesn't match, then we just skip it and move on to the next one. But I mean, the problem is still like, how do we remove words that don't match?
Yeah. So is there any way we can have? So you mentioned like you can sort. Is there any way we can like keep track of like what words are valid and what words aren't, so we don't have to keep because essentially we're shrinking our search space on every character, right? Like
mm-hmm.
we're not adding things that weren't there before.
I see. So we could, I guess, use essentially like a visited set or like some sort of way of saying the current word is valid, and if it is, then just check if it's still valid after the next character.
Mm-hmm.
Um, and if it's not, then we have to set it to invalid and then never check it again.
And are we ever
So
gonna have a case where like the first word is valid and the second word is not valid, and then the third word is valid if it's sorted?
if it's sorted, it should be, for example, if this one was invalid,
Mm-hmm.
that would have to mean, like, for example, like, let's say mobile was invalid and we had like MOU, right?
Mm-hmm.
And we sorted it. Um, these ones would not have to be valid either. So I guess if we sorted in reverse order, then no, that wouldn't make sense.
Well, I was more talking about like if we have this case, right? If we have MO, are we ever gonna have a situation where like a word is valid and then a word is invalid and then another word is valid, or are they always like valid, valid, and then not valid and so on? Like, are we ever gonna have like jumps basically?
yeah, my intuitions tell me that there's always going to be like valid, 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 or like invalid, 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 because since it's in sorted order, the characters, like the arrangement of the characters, have to be close to each other.
Right.
Um, so I guess using that,
Yeah. So if we know that like all the valid words are going to be next to each other, is there an efficient way we can like condense our space on every character and then like know what's there without using a try, with using just a sorted array?
sorted array. I mean, I guess we could just do like indexes of like 3 indices.
Mm-hmm.
Um, so let me think here. Yeah, so if the first one's invalid, then we can just increment all 3 indices.
Mm-hmm.
Um, and I guess we just keep doing that until we reach a valid case. And then we might have a case where the indices are out of bounds.
Mm-hmm.
And if that's the case, then we just check each index at a time once we see that the first word is valid. Um, I think so. That would be my approach. Um,
Yep. So basically, like you're saying, like we have three indices and we just like keep moving them until we get something valid, and then some
yeah.
of them might be out of bounds, or we might not have three, or we have to handle all that stuff. But yeah, that makes sense.
Okay. And I'm thinking of edge cases right now,
Mm-hmm.
like empty strings. Yeah, I mean, we just see if
So if you had an
the
empty string, and it was in sorted order, like where would your empty strings be?
So I know that when you sort a string, we're comparing like the ASCII values,
Mm-hmm.
and like for example, like I can't remember exactly what number, but let's say it's like 30.
Mm-hmm.
And if this is like an empty string, then I think that would be at the front if we're like in ascending
Yeah.
order. Um,
And let's
and
just
I,
assume for this problem, so that is right. Let's just assume our products are never empty and our search word is never empty. So we'll at least have like one character.
okay, so if that's the case, then we can just continue with like the same logic as before.
Mm-hmm.
Okay, I'm gonna probably start cutting this up because we're tight on time, but I
Sure.
think that's all the base cases for now. So uh, let's go ahead and go through that. So I'm gonna do products.sort, and I think this is in sorting, or this is in ascending order. So let's see. So if it's 30, yeah, this should be like I don't know how to explain. Like the smaller characters they come first. So if it was like
Yep.
A, they come first in the ascending order. Okay,
Yep.
and then we'll have our indices. So I'll just call it L1, L2, L3 is equal to 0, 1, 2.
Mm-hmm.
And then we'll just increment all of these by 1 until we reach a valid case. So and we'll have to have an answer. So I'm going to store that here. And then we're going to return it at the end. And then for char and search word, we essentially just keep checking the indices until they're valid. So if we have to do I guess we have to build the string. So we do that. So build string is equal to char, or sorry, equal to an empty string. And then we do build string plus equals char.
Mm-hmm.
And then for products, or sorry, for product and products, we just say if product starts with build string, then we can essentially add the indices. Otherwise, we would have to increment the indices. So L1 plus equals 1, L2 plus equals 1, L2 plus equals 1. And then since we would have to go back to the beginning at the end of this product checking, we can just do, actually, I don't know if we need to do that because, let me
Yeah,
think about
like
that
why
for a
would we
second.
need to go back to the beginning?
Yeah, we don't need to because we've already checked that the next letter is valid. Okay.
Mm-hmm.
So first thing I'm going to do is if they're within bounds. So if L1 is less than the length of, it would be the length of products. So if L1 is less than the length of products, then we can do, and we have to have another array here. So list words. Then we can do list words dot append product, and then we just essentially continue this for all the other ones. So products. Oh wait, this doesn't make sense. Obviously, hold on. This should be because it's an index. So hold on. So it starts with build string. It kind of went on a brain dump here. So let's see. If it was mouse, and we see that the first product works, then we have to add the other two products if they match. Okay, so this should actually be for I in range length of products. And I'm going to do, I think I could do -2 here, but I'm going to keep it at this for now. And then if it starts with the word, so I'm going to do products of I starts with the word, then we can check, or we can append the current one, products of I. But then we also have to check if L2 is less than the length of products. And if it is, then we can do
So why are
products.
you like on line 161? You're saying I'm going through all the products, but you have L1, L2, and L3, right? Which is basically like this is where I need to start searching from. But in 161, you're starting from the whole thing over and over. So why can't you just start from L1, for example? Because you know, like you've already searched through everything to the left of it, and you know that's not valid.
Yeah, that's right. For while L1 is less than the length of products. And then, yeah, okay, this is a little silly. Okay, and then products of L1 starts with a string. If it does, then we add L1 and then L2 if it's within the bounds, and then L3 if it's also within the bounds. So length of products. This words dot append products of L3.
Okay.
And then here we have to append it. So answer dot append list of words. Okay, so build string. So we have to build string. Okay, that makes sense. And then it starts with, and then we have to make sure that these are actually correct as well. So I want to say products of L2. That starts with build string. And essentially the same thing as well for the third one. I guess we can essentially just check. Like if we want to clean up the code just a little bit, we can just say this as well. And then just reduce the. Actually, I guess we can just keep it. It's fine. I think it should work either way.
Yeah, let's try running it and see if there's any bugs because we're a little short on time. So.
Yeah. So this is a class. So.
Oh yeah, sorry, I'm probably the class.
Oh, you're fine. Products. So. Mouse search word.
Right.
And then this needs to print. Okay, let's try running this.
Looks like we got an infinite loop.
Yeah, TLE. For chart and search word. And then we can just break out this loop here. Okay, is that the correct moneypot monitor? Mobile moneypot error monitor mouse pad.
I think so.
Yeah, that seems correct. I think.
So if product starts with, so basically you broke here.
Yeah, right here.
I see.
Yeah, because there's no reason to keep checking in this while loop once we have our.
Okay, got it. Oh yes, if you have it. Okay, once you have the first valid one, I see. Yep.
Yeah,
okay.
And then we.
Yeah. Okay, I think this is good. Okay, so I think we could stop here. I think this is right on time.
Yeah, a little messy on the second question.
Yeah. Okay. Okay, so for the feedback, I will say you did a very good job, like restating all the problems in your own words. You were like looking through the questions. You were kind of like, this is what it says, but this is what I think it says, and you were clarifying things. You also did come up with like edge cases. Some for a lot of these, so that was also good. Also, I think for the first one, you discussed one approach, which is fine. You can some better thing might be like quickly discuss multiple, like be like, I can do A or B. I'm going to go with A, and you don't have to go in depth about B. But I think for the first problem, like there's not too many things you could do. But the good thing is like when you like I've done these with a couple people and you described like what you're doing and it's very easy for me to follow and like clearly understand like what you meant when you were describing that, so that was good as well. You also stated the time complexity, which for the first problem, for what it's worth, was wrong because that string thing, but yeah, so that's good to know. The other thing you could have done that would have been a little bit better for the first one is but I think this is still like good enough, is you didn't have to break it down into links. You could have just done this like on the fly. So you could have just compared the two arrays on the fly, and then that would be like no space. Because you can store a character in an int that grows. Does that make sense? Like,
oh, you're saying like instead of parsing the input, just if it's like a string, just check it, and then if it's
exactly.
Okay.
If it's string, just check. If it's an int, then just parse the int and then jump the int.
Mm-hmm.
Yeah. But small thing, like for an interview, like if this helps you have a working solution that's like more error free because it's easier to code, that's totally fine.
Mm-hmm.
Let's see. Yeah. Oh yeah. The other thing is, so when you said your approach, I asked you for the time and space. I would just briefly say it like as you do it yourself. That would have been a little bit better. So as you described it, you can be like, this is whatever time complexity. Yeah.
Mm-hmm. Okay.
And then you did have a lot of bugs in your parse input, but luckily, so this is kind of like depends. Like if this was an interview where you can't run your code, it would have been very tough for you to find all your bugs because you had a
Oh
lot.
yeah.
So definitely, I'd work on that. Like try to have less bugs in your initial like coding solution. But the nice thing is because you were able to run your code, you fixed pretty much all of them. I think I pointed out one for you that was like would have been kind of annoying, but the rest of them you found, I think. So that was
Mm-hmm.
also good. So you can debug your solution, and I figured that string one was going to be annoying. I didn't want you to spend like 10 minutes looking for it, so that one was kind of
Yeah.
stupid. The other stuff was more relevant and like just errors. So yeah, so that was also good. And then let's see. Yeah, you talked through the code. It was very easy for me to say like see what you were doing. You had like good variable names. It was very easy to see like what's what. Your code was also pretty good. Like you had this like parse function that did one thing, and then you had the other function that did another thing.
Mm-hmm.
So it's also like very easy to follow. Yeah, you handled the. I think you missed a couple edge cases that I pointed out to you, like the zero and the obviously
Yeah.
the important one is them not being the same length. Like that one is like not good. So I definitely work on that. Try to come up with like all the different things. I don't know if one of those was an example, but yeah, because I feel like that one should be
Mm-hmm.
a
Oh,
little
that
bit
makes sense.
obvious. Yeah. So
Yeah.
definitely work on that. Like edge cases. And yeah, overall, I'd say like communication good, problem solving good, data structure knowledge good. Just write code
Refinement,
that's
right?
like
Yeah.
less error prone and come up with more edge cases. And then oh yeah, and then the optimizations. Yeah, I also had to ask you about like well, I guess it was just the string thing, so you didn't know. So honestly, that's not a big deal, but you can know
Mm-hmm.
for next time.
Yeah. What about
Uh,
the second problem? Because that one was a little messy for me.
yeah. So you once again you restated the problem in your own words, which is good. You talked about like basically different solutions, and you mentioned a try, which is good because like a try is like advanced-ish, I guess, and I think your solution would have worked. Maybe you could have done some things like said, "Oh, like how long are these words?" And then based on the how long the words are, maybe like a try is better or the sorted array thing's better. Depends, I
Mm-hmm.
guess. Um, and then you also were able to pivot into my suggestion, which honestly a try probably would have been fine. But you were like not hesitant to pivot when I was like, let's just do something else, and you were still able to like figure it out, which is also really good. Um, so and then let's see, yeah, and then your code was pretty solid as well. I mean, I think I mentioned like one or two things just because we were like a little bit low on time, but it wasn't like the biggest deal.
Yeah.
Um, and then also it was like very easy to follow. I mean, some simpler things you could have done was like instead of having L1, L2, and L3, you could just have L1 and then just manually check for the two after. But that's
Mm-hmm.
also not a big deal. And yeah, you basically when we didn't have a lot of time, you were able to code it and have it all work quickly. So I'd say like for your problem solving, it was like very good. Um, so I'd say this is like probably like strong high or something. I think for the coding, it was like clean, but there's a lot of like bugs. So I'd say this
Yeah.
is like 2 to a 3. Your knowledge of DSA was very good. Like how many LeetCodes did you say you did? Like 350 or something?
Yeah, like 300-ish, 200, 300.
Yeah. So if you did 300 and like tries and stuff, that's also quite good. So I'd say this is also like
Yeah.
3 to a 4. And then your communication was like very good. So yeah, I'd say this is like somewhere between like a like like a strong hire and like especially for text screen, I think it would be a strong pass in my opinion
Mm-hmm.
because you were able to finish anything. You had some small bugs, but you basically figured out all of it on your own, and yeah. So I think
Cool.
for an on-site, it would probably be like obviously how competitive it is. It would probably be like a week pass.
Yeah,
Just
it
because
definitely needs
there's a lot of
more
things you could do better.
refinement. That makes sense.
Yeah.
Okay.
And then the other thing is, I guess, speed, right? Like you barely finished on time. You could have like this is doable
Yeah,
in 40 minutes if you work
I was a
faster.
little worried about that because I know I was kind of going a little too long in the explanation, and, like the
Yeah, that's the
examples.
other thing
But
is like a lot of the things you don't really have to like you're like, oh, in a lexicographical small string, like the characters that appear first, or you like all that stuff. It's like you should assume that like if I give you a problem, I'm already familiar with the problem. Like you don't really have to break down too many things unless it's like very complicated. Like most of the things I was like, I didn't want to be rude, but I was just like, you don't have to explain this thing, like I know it already. So
mm-hmm.
so that definitely could be another, yeah, try to figure out a way how to explain things but not over explain, and just like do it very quickly.
Mm-hmm.
And then
Okay.
if anything, you can just explain things very quickly and then be like, is this good? And then if I have more, if I'm not good, then I'll let you know. And I definitely had some of that where some people explained the solution but it was very unclear, so I was like, no, I need you to like explain it a little bit more detail. And yeah, you basically had like working, like pseudocode or whatever, or like the plan before you
Mm-hmm.
coded, which is also quite good. A lot of people just like don't really, they just say something and they're like, can I code? They don't, where it's like, I don't think they really know what they're trying to do. And then what ends up
Mm-hmm.
happening is they start coding, and then like 20 lines in, they're like, oh crap, this doesn't work. Let me delete it all and try again. That's
Yeah,
like
that
very
makes sense.
common. A lot of people actually don't even like explain anything. They're just like, let me just start coding and see what happens.
Yeah, I actually did that in my last interview, and yeah, it screwed me over pretty
It
badly.
works
So.
sometimes, but you have to really know what you're doing. And if you don't,
Mm-hmm.
then if you're like writing a bunch of code and deleting it, then like if you have a good plan and it's solid and it's very clear, you can write the code in like 5 minutes. So it's actually faster to like think of what to do and explain it and then code than to just like YOLO code, unless you're like very good at it and you know what you're doing.
Mm-hmm.
So but yeah, overall, I think this is quite good. Just work on yeah, like speed and less bugs. So maybe if you want to schedule another one down the road, we can do one where you can't run anything, and then you can't just rely on like running stuff and seeing what happens and like fixing everything. Because that's like another common interview format I know
Yeah.
for like Meta and Google and all that stuff. Like you can't run your code, and then if you have like 10 bugs, it's kind of hard to find it by reading through it.
Mm-hmm. Okay. Yeah, I really appreciate this. It's really helpful.
Okay,
Um,
cool. All right, well,
cool.
I'll see you later.
All right. Thank you. Bye bye.